Hello, Mr. Luong. This is my FRQ number 5. So for part A, this is what I'm going to draw for a free body diagram. So the forces acting on it are Fg. And then there's also the F force acting it downward like this, an angle. And then there's also Fk, and Fk is gonna look like there's less than Fx, so it's gonna be like around there. I'm gonna raise the Fx. And then there's also F and Y, but the F and Y, there's also Fn. Wait, let me label this F. This is Fk. And the Fn is going to look like a lot greater than the Fg, because the Fy, there's like Fy and there's, sorry, this looks kind of bad. But there's like both Fy and Fg, so the Fn is going to look like a lot greater, like this much, I think. Yeah, somewhere around there. And that's Fn. Okay. For part B, I know that to find the contact force, I have to add both the Fny and the Fny and the Mgy. Yeah. Oh, so before the Fn, before the Fn was gonna be both the Fny and Mgy. So that's why it looks greater like that. Not the Fg. Sorry. Yeah, but Fny plus Mgy. So that's why Fn looks greater like that. Okay. Next one for part B. So like I said before, the Fn is going to be both the Fny plus Mgy. So it's going to be Fn equals to F sine of theta plus Mg cosine theta. And then for part C, it's going to be a lot of writing. So the F cosine of theta is the Fx, but then you also have friction acting against it and the force of gravity in the x direction acting against it. So you have both friction and Fgx. So friction is going to mu k Fn, and then I plug in Fn for what I got before. So F sine of theta plus Mg cosine of theta minus Mg sine of theta equals to Ma. And then I divide both sides by m to get acceleration. So F cosine of theta minus mu k F sine of theta plus Mg cosine of theta minus Mg sine of theta all over m. Okay, for part D, I know that for for the block to slide with constant velocity, acceleration will equal to 0, which then makes the force F cosine theta equal to the forces acting against it. So that's why it's going to be I'm going to make my equation F cosine of theta equals to the friction plus the force of gravity acting against it. So then I just divide both sides by cosine of theta, and then I also distribute mu k to both F sine of theta and Mg cosine of theta. So then this is going to be mu k F sine of theta over cosine of theta plus mu k Mg cosine of theta over cosine of theta plus Mg sine of theta over cosine of theta. So then F can be simplified into mu k F tan of theta plus mu k Mg plus Mg Tana data, but then you still have the F here, so you gotta subtract that to the other side. And then for this side, there's both mg, so I can take mg out. Okay, and then I can take f out, so then that'd be mu k tan theta equals mg mu k plus tan theta. And I divide both sides by that to get mg mu k plus tan of theta all over 1 minus mu k tan of theta. Okay, so F equals to mg times mu k plus tan of theta over 1 minus mu k tan of theta. And then the second part asks for like what relation do data and mu k have to satisfy for the solution to be physically meaningful. And for me, what I think you mean by that is that the mu k and like the product of mu k and whatever data is for the angle, like they both have to be less than 1, because if both of them multiply whatever and they become greater than 1, then the force becomes negative. And you can have like a negative force that, because that just doesn't make sense. That means it's not gonna accelerate at all. It's just gonna accelerate. Yeah, it's just the force is friction acting against it. So no, that does not make sense. The force cannot be negative. And if it's just 1, it also doesn't make sense, because like that means undefined. So I think mu k and data have to be less than 1. So for part E, it is going to be a lot of work, but I'm just gonna use the equation I wrote before right here. I'm gonna use this equation right here and I'm just gonna plug in all the values you gave me to solve for the F. Okay, so I'm not gonna rewrite that, or I guess I can copy and paste. Hold on. The great advantages of having technology. Okay, paste right there, paste. Ooh, nice. Okay, this, actually let me move that to the other. Oh, where do I move? Wait, no, I don't want this. Oh, wait. Oh no, how do I, wait, oh my god, this is so stressful. Okay, let's move this down here so I have more space. Okay, excellent. Now this is part E. Okay, I'm gonna plug in cosine of 20. So I'm just gonna write that out for you. Write everything out that I'm plugging in. And then F sine of 20 plus 2g cosine of 20 minus 2g sine of 20 equals 2 times 0.5. And then when you do calculator work with all the cosine 20 and sine of 20, this is what you like, the rounded numbers. And then I distribute 0.3 to the sine of 20 and the 0.3 to times 2 times 9.8 times cosine of 20, so which is gonna get me like 0.11 f and minus 6.08, and 2g sine of 20 is minus 6.7, and then that equals to 1, and then you add like terms, so it's 0.83 f equals to 13.78, and F should be around like 6.67 Newton. Yeah. Okay. For part F. So for part F, it's going to be like basically the same thing as the part. It's part F is asking for the same thing as part, where was it? Part D, because for an object to be motionless, the forces pushing up and against it have to be equal for it to not move because acceleration equal to 0. Therefore, you can make F cosine of theta equals to the forces acting against it, which are friction and the force of gravity So F, I'm going to basically, where is part D? Okay, I'm gonna do the same thing like before, except I'm going to I'm gonna add 5 in front of the M because now I'm gonna look at it as like a whole system. So I can just add both M and 4M together to get 5M. And then I'm just gonna look as one system. So the force of acting against it, I'm gonna look at as like the Fn of 5M, and then the friction. So yeah, so that's how I'm gonna derive Fn, is by looking at the mass as 5M, and then same with the FGX, I'm gonna look at it as 5M. Okay, right here. Now I'm gonna add the 5 plus 5 plus 5. Okay, and now I'm going to solve for F again. And if I go all of that over cosine of theta to get F. Then for part G, I'm just going to use the same equation right here. I'll use this equation right here, except like I said before, add 5 in front of the M. So I'm gonna plug in all the values. Yeah, so this part is the same as before, but right here it's going to be minus 0.33 times 5 times 2g cosine of 20 and then minus 5 times 2g sine of 20 plus 5 times 2 times 0.5, and then this is going to be 0.83f minus 30.39 minus 33.52 equals 5, and then 0.83f equals to 68.91. Oh wait, did I forget a 5 up here? Yes, I did. I'm so sorry. It's not supposed to be F, that was a 5. 5 times 2g. Okay, everything all good. And then after that, you should get F equals to 83.34 newtons. Okay, so for part H, I know that Fm of 4m is going to be equal to F4m and m. And then I know net force of total is going to be max, and then net force total is also going to be 5 times 2 times 0.5, which equals to 5. And then the net force total for 4m is I'm gonna use the mass percentage times net force thing. So 4m, 4 times 2 is 8. And then over total, because 8 plus 2 is 10. And then times 5, that's the net force. You get 4 newtons at total acting on the 4m. And then I know that the net force total acting on 4m is gonna be the contact force, subtract the friction, yes, and this is the from mu k times Fn, and this is just the FGY for 4m because that's the Fn, and because that is just Fn like that for, so Fn equals to FGY for this one because the force isn't touching 4m. And then once you plug in all the values and then you move, so 4 equals to 4m4 minus, that's going to be wait, how about I just add up all of that to the other side so it can save time. So I'm gonna add 4 plus whatever this equals 2 to the other side, plus 24.31 plus 26.81 equals to Fm4m, and Fm4m after calculator work will be 55.13 newtons. Okay, last one, I think. Yes, this is last one. I. So net force total of 2m is going to be the Fs acting, pushing up. There's also Fg acting, Fgx pulling it down. So then Fs can be expanded to mu s 2mg cosine of 20 minus 2mg sine of 20 equals to 2m 0.3. Then odd m's cancel out, and after that you mu s 2g cosine of 20, you add the 2 times 0.3 plus 2g sine of 20 to the side, divide this by 2g cosine of 20. Mu s should be equals to around 0.397. Okay, that is all. Goodbye. Thank you. I mean, not goodbye. That sounds very rude. Thank you for